This protocol allows the novel physical transformation of chitin, a high-volume waste material that is notoriously difficult to work with.
The main advantage of this technique is the simplicity of the processing methodology, as it does not require specialized materials, only the basic equipment commonly found in chemistry laboratories.
We demonstrated this method with chitin, but this technique can be modified to create expanded versions of other polymers and biopolymers that form gels.
In the simplest version of this technique performed as demonstrated, patience is important. The gelling rate will change with daily and seasonal changes to humidity.
One day before preparing the expanded chitin, dry at least 1.2 grams of chitin flakes for 24 hours in an 80 degrees Celsius oven. The next morning, in a fume hood and wearing chemical-resistant gloves and goggles, add 15 grams of lithium chloride to 285 grams of DMAC in a 500 milliliter Erlenmeyer flask containing a 50 milliliter PTFE-lined magnetic stir bar. Cap the flask with a rubber septum and place it on a heating stir plate. Place a temperature probe into the mixture through the septum and stir the mixture at 400 rotations per minute at 80 degrees Celsius for about 4 hours. When all of the lithium chloride has dissolved, add 1 gram of the oven-dried chitin flakes to the 5% lithium chloride DMAC solution and transfer the resulting solution into a 500 milliliter round-bottom flask containing a 50 milliliter PTFE-lined magnetic stir bar. Place the flask capped with the rubber septum on a stirring heat block. Pierce the septum with a needle to allow the flask to vent and heat the solution at 80 degrees Celsius with stirring.